Okay, let's today revolve about lines that are not in axis. We've revolved about the x-axis, we've revolved about the y-axis, we've even introduced a second curve to revolve about the x-axis and to revolve about the y-axis, which would generate a washer, just a cylinder that has another hole within it. What if we want to revolve about a line that is not the axis? For example, let's say we have a region bound by the graph of y equals radical x, y equals 1, and x equals 4, and let's revolve it about the line y equals 1. So that graph would look something like this, and this is a rough sketch of the region. So here is the function y equals radical x, here is the line y equals 1, and here is the line x equals 4. So we want to revolve it about y equals 1. So the region that we will be revolving about is this region here. So now let's first consider our line of revolution. Our line of revolution is horizontal. So we're going to be revolving about this line. Now, if we were to draw a representative rectangle of the region that we were looking to revolve, remember, I'm always drawing my rectangle from my line of revolution. So this is my representative rectangle. This is going to give me a lot of information. It's going to tell me that I have a delta x width here, which tells me that I need x limits of integration. So before I even begin, I'm going to determine what are my limits of integration. So now this is, again, as its name implies, representative of every one of the infinitely many rectangles within this region that will be revolved, creating a cylinder. So we want to start making rectangles at this ordered pair here. We want to stop making rectangles at this value here. These are both x values because of my delta x width of my subinterval. So if this is the line y equals 1, and this is my line y equals radical x, I can solve for that ordered pair there and say radical x equals 1, set these equal to each other. So I know that this is x equals 1. I was given that this is x equals 4. So I just found my limits of integration. And my limits of integration now I know will be 1 to 4. So I'm going to have pi times the integral from 1 to 4. Now, our last lesson, we introduced washers, which means we were revolving two different curves. We have a single curve here that will be revolved. So what's going to happen here is that this region is going to be revolved. So that's what we're going to have. We're going to have a single curve being revolved about the line y equals 1. So there's a single cross section which will be a solid cross section. So we don't have a hole, so we don't need to subtract another volume. What is going to be tricky here is, what is this width? Moving forward, what will be increasingly important is recognizing that we can only measure from an axis. I know that this distance from here to here is y. That's the curve. This distance here I know is 1. So now if I take a look at these two distances, their difference will be my representative rectangle. So it's simply going to be y, subtract that 1 from underneath. But what does y equal? Radical x. So what is helpful is drawing yourself a couple of representative rectangles. I know that this here is y. I know that this here is 1. And if I even put this right up next to it, it is a little easier to visualize here. The difference that will create our region here. So if we take a look, what we have is this sort of a region to That doesn't really pop that much. Let's see. Here. So now I have this whole thing, which is y. This is what I want to revolve. So from this, I want to subtract that. But what's that? This is y equals 1. I want to subtract these two values, and that's my region here, which will be my radius. So my integral will be radical x minus 1 squared. And that's it. There's no hole involved. So it's important to use these rectangles to understand what the region will be that's being revolved around. Let's say we want to revolve about a different line. Let's use the same region that we discussed, except now we want to revolve about the line x equals 4. So here is our line of revolution. Okay? We're still using the area bound by y equals 1, y equals radical x, and x equals 4, except now we're revolving it about the vertical line. Let's draw a representative rectangle of the region that will be revolved. Start from your line of revolution and trace it over to the curve. Where that second one come from there? So here's our region that we're going to be revolving about the line x equals 4. And we'll color that in help and pop. So here's our region that we're going to be revolving. Now, this has a width of delta y. That tells me that I want not only y limits of integration, but I also want a y integrand. I had the function y equals radical x. So let's solve for x to see what x equals. Square both sides, y squared equals x. So now I can call this curve not y equals radical x. I can say that this curve is, I can say that this curve is x equals y squared. Okay, so now that's going to help me determine what my radius is going to be. So now this is the region that's being revolved. This is a single rectangle that's being revolved about the line x equals 4. Again, we only know how to measure from an axis. I know that this distance from the axis to the curve is x. What does x equal? Y squared. This distance is 4. And how do I know that? Because this is the line x equals 4. So now that means this region that I'm looking to revolve will be 4 minus x. Because if I take these two regions and subtract them, I'm left with the region that I'm looking to revolve. So start with the outer radius here, from your line of revolution, all the way over, which is 4. Subtract your x value. What is x? Y squared. So there is my interval. Don't forget pi is a constant multiple, and I'm going to have 4 minus y squared. Don't forget to square. And the last thing we need is, where do we start making rectangles? Well, we're going to start making rectangles right here. That's the line y equals 1. I'm going to stop making rectangles up here. That's at the intersection point of x equals 4 and y equals radical x. But if I say if x equals 4, square root of 4 is 2. And there's my interval.